Hello students, welcome to our power measurements with dynamometer type wattmeter lesson. In previous classes we have seen power measurement in three-phase circuits for a balanced load. We have used single wattmeter method. For unbalanced load, we have used three separate individual 3 wattmeters in each phase to measure the total power, and in 2 wattmeter method we have connected for a load of balanced and unbalanced condition, and at the same time we have derived under balanced condition with instantaneous powers as well as RMS values. In terms of RMS values, we have drawn vector diagram. From that vector diagram, we have proved that total power consumed by motor indicated in 2 wattmeters only, that is equal W1 plus W2 will give the total power consumed by motor. At the same time, so we subtracted W1 minus W2 will indicates the that is equal to reactive power. So VL IL sin phi, we derived that also. At the same time, we found that the phase angle, the phi also with help of given 2 wattmeters. From that, we found that power factor of load with help of 2 wattmeter readings. Okay. Now, I have the one doubt. While using these famous 2 wattmeter methods in our electrical field to test of a 3-phase squirrel cage induction motor on no load test and blocked rotor test, I have observed that 2 wattmeters connected, 1 wattmeter in one phase, another wattmeter connected in another phase, and one phase is a common, that is a W1 W2. In that case, W1 is very sincere just like this Ramudu is always shows the reading, that is the pointer which is moved from 0 to some positive value only, whereas in W2 his brother, that is a Lakshmana, is where is varied the reading from sometimes it gives the positive value, sometimes 0 value, sometimes a negative value, but Rama always gives same positive value, and sometimes Lakshmana will shows the reading below the 0 reading also. So I may be confused. So reading may be from 0 to and clockwise direction, positive direction on calibrated scale, but this Lakshmana sometimes will shows the reading below the 0 value. There is no calibration on below 0 value. Then how can I know this exact value? That purpose my mentors will tell, no, you have to stop it and you have to change the CC coil or PC coil, either of this coil that indicates the value in positive value, then take it as a negative value. So I have stopped that, I changed CC coil terminal, then I started the experiment, then it moves in positive direction W2. Then whatever the value that taken and prescripted by negative value, prefixed by negative value. Once the load is added on induction motor, Once again the value comes to the 0 value once again. Then I asked my mentor what to do. Then remove that and replace, keep it original values. Then once again I changed the CC coil terminals and started the motor. Then the motor is run, then it is giving the positive value from that load. Why it is happened? The W1 always showing the positive value only, but whereas this W2 value, it is showing the reverse direction, it is showing the 0 direction, it is showing the negative direction, and sometimes it is showing the positive direction. What is the reason? My mentor told me that is this W2 wattmeter and W1 wattmeter shows its deflecting value based on the power factor of machines. That means if the power factor of machine changes, the readings of and W1 and W2 changes. But so W1 is the Rama, single person, he can handle anything. But whereas the Lakshmana, sometimes he will what is the calm person, sometimes the angry person. That's why it changing values from reverse direction, 0 direction, negative direction, and positive directions. How? So we will see in this class how the wattmeter values changes. Okay. So this is our aim. So we will see all these values with example how the power factor changes, then W1, W2 value also how it changes and its behavior. Okay. This is our main prime. Now let us learn this changes of W2 corresponding to power factor changes. Okay. Now let us prove it, whether the power factor angle 0 degrees and power factor at 60 degrees and power factor angle 90 degrees. We will see what is going to happen. That means when the power factor is unity power factor, when power factor is equal to 0 value, when power factor is equal to 0.5 angle, and it changes how the behavior of W2 changes, we will see. Okay. Now study of effect of power factor on wattmeter readings in 2 wattmeter method. So what is the 2 wattmeter method? Just you can see it. You have seen. So you are connected and here are connected. And CC coil is connected. Here this is CC coil PC coil connected. This is a CC coil, this is a PC coil. Okay. Here. So this is equal W1, this is equal W2. This is equal to, we can see the VR, VY, VB. Last class we have seen. Similarly, we have drawn the vector diagram also. Okay. Now based on this one, we are going to. So it is a total power is equal to the W1 plus W2. So we are going to get it. What is that is called? √3 VL IL cos phi. Okay. W1 minus W2. I am going to get it. So VL IL sin phi. Okay. These two equations we drawn. At the same time, what is the power factor? Tan phi. The tan phi also we have drawn that it is √3 and W1 minus W2 by W1 plus W2, and we derived these three basic equations in last class with help of phasor diagram. Okay. So, now in this case, how the power factor changes, the power angle changes, this angle changes. So, what is the effects of this W1 and W2? Okay. Let us see. Now, you can write it. W1 is, can I write it? W1 is equal to VL IL cos 30 minus 5, already derived. W2 is equal to VL IL cos 30 plus 5. Okay. So, these equations already, this the readings of these equations already we know this one. From this one we calculated this all things, and now this is once again taken these values. Okay. Now, let us take the one case when the load is equal to unity power factor, UPF. Okay. So, the load is UPF. So, in this case, what is happened? UPF, that means whatever the voltage, for example VR and IR also same thing. Okay. What is the phase angle? The V into I into cos phi. The phase angle both are, what is the angle here? This the angle phi is equal 0 in phase. Okay. Cos phi is equal here 0. Cos 0 is equal to how much? 1. So, that is equal to phi angle is equal to V into I into cos 0. Then we are going to V into I. At that condition, the PF, what is the power factor? Cos 0 is equal, we are going to the PF power factor is equal to 1. That means first case, so write it here. First case, what is the case? I am doing it case 1. Case 1, when load nature is UPF, that is equal to cos phi is equal to 1 and angle is equal to 0 degrees. Okay. So, this is, that means the voltage, whatever the this voltage and current are the same angle. Okay. So, both are same angle. At that condition, what is the W1 value and W2 value? Okay. Simply substitute. What is the W1 value here? W1 is equal to, what is the W1? W1 is equal to, so what is the formula here? So, VL IL cos 30 minus 5. Okay. So, here it becomes to the, this value becomes to 0. Okay, from 0. Then we are going to get, what is the value? That is equal to VL IL cos 30 only. Okay, cos 30. Cos 30 is equal to root 3 by 2. That is equal to root 3 VL IL by 2. So, this is the value. W1 indicates the this value, that means positive value. Now, what is the W2? Now, write it the W2. W2 is equal to VL IL cos 30 plus 5. Okay. So, now it becomes a 0. Now, we are going to the same value. So, that is also, so that is equal root 3 cos 30 is equal to root 3 by 2. So, and then we are going to the same value root 3 by 2 VL and IL. So, this is second. That means here W1 reading is equal W2. This is the case when UPF. Okay, so both are positive values and equal values. Whatever the W1 indicates, suppose 40 watts, W2 also indicates the positive 40 watts. W1 indicates the 80 watts, it is also indicates the 80 watts. Now Rama and Lakshmana are both same direction and both are equally in magnitude and direction. Okay, so both are positive values and both are equal values. W1 is equal to whatever the Rama will do, Lakshmana also will do. Okay, both are moving, and that means here if you take the wattmeter, W1 and take the W2, Lakshmana and W1. Okay, so that is what is the reading. If you are saying the reading, so you are going to this one readings. Same readings you can take it. So whatever the indicates, for example, W1 indicates this reading and this also indicates the same reading. So W1 is equal to W2. It is moving, there is a positive direction, this is also moving in positive direction, the first case. Okay, now coming to the second case. Now you take the second case. What is the second case? Case 2. Now in this case, take the phase angle power factor 0.5. So PF is equal to 0.5 lagging. Now what is the cos phi? Cos phi is equal to 0.5. Then phi angle is equal cos inverse of 0.5. We are going to the 60 degrees. That means here the voltage this direction and this is equal, current is equal this direction. Phase angle is equal 60 degrees. Okay, so VL and IL, so phase angle is 60 degrees. In this case, and we are going to see that is a performance of Rama and Lakshmana. Okay, now take the Rama first of all. Now what is the Rama? So what is the value? W1. Okay, so W1 is equal to VL IL, okay, cos 30 minus 5 Rama values. Now what is the far angle? 60 degrees. Substitute VL IL cos 30 minus 60. Okay, then so what is the value? So VL IL, so minus 30. So cos that value becomes the positive. So it becomes the cos 30 only. Okay, now what is the cos 30? VL IL into cos 30 is equal to root 3 by 2. That means, so we are going to get the power that is called root 3 VL IL by 2. This is the W1 reading, Rama reading. That means it's showing the positive value only. Okay, now coming to the Lakshmana. So you take the Lakshmana. Okay, you take the Lakshmana now. So W2 value is equal to VL IL cos 30 plus 5. Okay, then VL IL cos 30, what is the 5? 60 degrees, okay, plus 60. Okay, then what is the value? Cos 30 plus cos 90. Okay, na? VL IL cos 90 degrees. So what is the value? It becomes to the 0. then 0 into something, VL, IL into 0. So that means this value becomes the 0. So W2, Lakshmana at this condition, simple, idle. What will happen? The Meghanada shooted arrow. Okay? Now W2 is equal 0 condition. So that means here W1, okay, W1 indicates some value. Okay, so from this one scale better, so 0 something 0 to this value indicates, whereas Lakshmana, so what is happened? W2, so only at 0 only, no indication. So W2 and W1. What is the conclusion? The total power is equal. Now in this case, so total power consumed by only burden and rama only. The total power is equal to total power is equal to, so here W1 plus W2, in this case, so only W1 indicates. Okay, W1 only. Now W2. Now only W1 indicates the total power consumed by the load indicated by the only W1. W1 will give the total power taken by load from the supply. At that condition, our Lakshmana under coma. So when Meghanada is shooted by Maya Astram, then what will happen? Is fallen on the ground. Then Hanuman helped him to wake up. So at that period, so only the Rama is the hero in this case. Okay, now this is the second case. What is the second case? When power factor of the load is exactly 0.5 lakh. At that condition, the phase angle between the voltage and current is how much? 60 degrees. So here the angle is 60 degrees. At that condition, Rama W1 is the burden total, and W2 Lakshmana under coma is a fall on the ground. So total power is just total is faced by the war is only faced by the Rama. At that instant, at initial starting of the war, when power factor is equal 1, that the phase angle is equal 0, then both are in positive direction. After middle of this one, the Ravana son shooted the Lakshmana fall on the ground, then only the hero at that time W1 total look up the war. Similarly, in this case, total power consumed by our motor indicated by the only W1. So dear students, have you understood it? Now take the another case. Okay, the third case you take it. Now what is the third case? Now we can take the third case. Okay, case 3. What is that? Then when power factor is equal 0, that means the voltage VL and IL both are 90 degrees quarrel each other. Okay, both are 90 degree each other. That means the angle is equal to 90 degrees, power factor is equal 0. At that condition, what are the situations of W1 Rama and Lakshmana? I want to know. Okay, similar method. Will you try it? Please try it. Very easy, simple. You substitute the angle 30 minus 5. The 5 is equal 90 degrees. 30 plus 5, 90 degrees. Simple substitute. You are going to get the behavior of W1 and W2. Okay. So let us try it. Okay. So I will explain. Don't worry. So what is the, once again write it. What is the rama W1 is equal to VL IL cos 30 minus 5. Okay, this is the rama attitude. Then what is the phase angle? The phase angle is equal to 90 degrees. Current, voltage, phase and 90 degrees. Then substitute VL IL cos 30 minus 90. So we are going to get its VL IL, so 60 minus 60. So cos, anyway cos, there is a cos 60. Okay, what is the cos 60? The cos 60 is 1 by 2. Then we can write it. So VL IL into 1 by 2. So this is the behavior of rama. That is the total power by 2. The reading by 2 we are going to W1. VL IL by 2 half of the load. Okay. So this is the value. What is the value? VL IL by 2. We are going to get it W1 value. Now coming to our Lakshmana. So we take another color, Lakshmana. What is that Lakshmana? W2 is equal to VL IL cos 30 plus 5. I think you got it. Okay. Now VL IL cos 30 plus 90. Okay. So substitute. What is the value? This one, 90 substituted. So we are going to get VL and IL cos 120 degrees. Okay. Then so we are going to get, what is the value? That is equal to minus value you are going to, that is equal to, so we can write it 90 plus 30 is equal to minus sin 30. Sin 30 is 1 by 2. So we are going to minus VL IL by 2. This is equal to W2. So in this case, Lakshmana, the magnitude is same but is a negative direction. Okay. So what is the W1? W1 is the same. This is a positive value. Whereas the Lakshmana minus VL IL by 2. So same value but is a negative value. That means here, so first our rama, so indicates the wattmeter reading. Okay. So this is the reading 0 something something something, then indicates the some value of support, for example this value. So indicates from 0 to the positive value indicates. Whereas our Lakshmana, what is happened? So here our Lakshmana, so this is the reading W and 0 something something, but it indicates this direction. But values are this direction. So that means, so this, what are the value here, this length here is this value, but it's a negative value. So W1, W2. That means what are you going to do? In this case, Lakshmana, we have to change its attitude. After this comma, it changes the values. This is this values. Now here what is happened? Here this is a CC coil M L. So we connected this wire coil, and this is a PC coil. So C and V. Now we connected the supply from M. Sorry, we take this one CC coil, and we take the load from this one. We connected the load, and M and C shorted and V is connected here. So at that condition, its behavior is reverse direction. Now I want to move this direction. What to do? So I can, the CC coil current is now flowing this direction only. So you can see here, dear students, don't confuse. That means the current is flowing this direction. Here the current is flowing this direction. So at this condition, the flux developed, the torque developed is instead of moving clockwise direction, it is moving this direction. Okay, this direction. So I want to change this one. So as you know that in DC motor, so the motor of the DC machine shunt motor can be changed its direction, whether you are going to change the armature terminals or field terminals, not both. Okay, what you have seen in DC machines. Okay, have you remembered that thing? So what has happened in DC motor? So here this is some DC shunt motor, you take it. Okay, this is the this one. Okay, so the DC motor is the current is taken A and AA, and this is Z and ZZ. Okay, in this condition, when the current is flowing this one, it is moving this direction, for example clockwise direction. So I want to change this direction in anti-clockwise direction. What to do? So simple, I can connect, this is equal to here and A and AA terminal. Now this field which is having the ZZ, I connect, this is equal to here and this is connected to here. Now it is given this one. So automatically the speed will change this direction. Okay, now what is happened? So I connected whatever the A and Z is connected here. In this case A and ZZ connected. So in previous cases the current is flowing Z to ZZ. In this case the current is flowing ZZ to Z. So I changed this direction. Sir, I don't want to change the field current, sir. Then how to change? I want the speed in this direction. I don't want this one. Then simply you can change the armature terminals. So how we are going to change the armature terminals? Simply you connect it. Okay. So now he is connected this one, Z and ZZ, and this is A and AA. Then so you are going to connect this is a supply, direct supply is connected to the Z, and this is connected to the direct supply, and now the terminal whatever the supply is connected, this one connected to the this AA. Now it is connected to the this one. Now this is a plus, this is a minus. Now automatically the armature terminals here, armature terminals are changed. In this case field terminal changed, not both terminals. Then the speed will change from regular direction. Similarly here, whether you are going to change the CC coil, what is the CC coil? M and L, and whether you are connected the PC coil, that is equal C and V. In first case, so what is happened? Here the current is flowing this direction and the current is flowing this direction. Okay, color is flowing this direction and current is flowing this direction. So that's why the meter indicates the deflection. Instead of due to the power factor effect, the deflection, the pointer will move this direction, moved in this direction. Deflecting torque is produced in opposite direction. Now once if I change this value and this value, now what will happen? The current is flowing this direction, this direction. Here is the same. Okay, now the current is flowing this direction in this case, and this is as usual. Then the torque produced in this reverse of this one. Then pointer will move this direction. Okay, whether you are going to change the CC coil terminal or PC coil terminal, only one of this one. Okay, so this is we can do while doing in practical. Okay, so these are the some different cases of our load. Let us see in Same thing in salient points and power point. Okay, so here what is the power point? So this already we have seen. Okay, so this is W1, Rama and Lakshmana. So by this one here already we have seen. Now, so we calculated everything here and we power factor also. Now effects. The first case, what is happened? So in this case, the power factor is case 1, power factor is 0.5, exactly 0.5. That is equal power factor angle, the voltage and current. This is volt, this current, angle is equal to 60 degrees. At that condition, what is the W1, what is the W2? Okay, so here we have seen. So W1 is equal to root 3, this one, this. Now, and W2 becomes the 10. In case 2, when power factor is equal to less than 0.5, that is less than 60 degrees. That means here the power factor, this is a V, this is equal I, the power factor, this angle. So less than this angle, what is the values? Exactly 60 degrees, this is a value, and in between this value, how it will changes this value. Okay, and so we are going to the W1 and W2 are both in positive direction. Okay, both are reading will shows in positive direction only. The deflecting torque produced in W1 and W2 in positive direction, that is the clockwise direction. In case 3, if the power factor greater than the 60 degrees, okay, that is the here. So dear students, please don't confuse, this is equal to V and we taking the T references. So this is a 60 degrees. Okay, the first case, what will happen? Exactly 60 degrees. Exactly 60 degrees. What will happen? W1 Rama is positive value and Lakshmana under coma value. Okay, if the value is less than 60 degrees, this value, this range, in between this range, what will happen? The Rama and Lakshmana both will show the reading in positive values only. Next, if the power factor angle, so in this case, if the angle is here, this area, in this case greater than the 60 degrees, if current comes this area, okay, that means you can see it. So this way, suppose current is this direction up to 90. So in between, what is the area? So in this case, so we are going to get it. So what is the value of that one? Okay, so what will happen? So here the W1 becomes to the positive, because Rama is always positive, and whereas Lakshmana, W2 becomes to the negative value. So it is coming the negative value. Okay, this all already we discussed. Okay, now what are the salient points? That means the second wattmeter deflects back and connections are to be changed for getting the reading. Just we have seen whether you are going to change CC coil or PC coil of a wattmeter, then a reading will reverse. That is why we say that the total power in 3-phase circuit is the algebraic sum of 2 wattmeter readings of 2 wattmeter method. If it is a 3-phase 2-element type wattmeter, no need of changing connections as a 2 wattmeter method is used. So what is the meaning this one? For example, in this case, I used W1, I used W2. Okay, so here connected in one phase, I connected another phase, and here I connected so this phase is simple 2 wattmeters. Then either of this W1 and W2. So if the power factor changes of the load, it will draw the current, then this readings values changes. W1 always shows a positive value, but its W2 value sometimes the 0 value, sometimes the negative value, sometimes positive value will shows. Okay. So if connected two wattmeters separately, if I connected 3-phase wattmeter, that means here 3-phase wattmeter is consist of, so here I consist of some meters and the terminals. So this is one phase, or this connected the another phase. Then it will give the reading at a time. So it multiplies. This is the W1 and W2. So there is a two coil, CC coil, PC coil. It has a common spindle. It is connected in the pointer. So whatever the minus value, positive value, subtraction, all will take care of this inside. So that is the 3-phase wattmeter, 2 element meters. That means it has a CC coil and PC coil, and CC coil and PC coil. Common spindle is provided. That common spindle, so based on the first coil torque, based on the second torque, so resultant torque will move the spindle, that will shows the reading on a reading. So that will gives a direct value. No business of changing CC coil and PC coil, no business of writing the minus value in where you have changed the CC coil terminals. Okay. So 3-phase element, 3-phase 2 element wattmeters generally used in our laboratory. Okay. And incorporated in it using the 2 unit combined together to move a single pointer on the scale. So this already we have seen a 3-phase wattmeter constructions. Okay. Now, so let us summarize what we have seen in this class. Okay. So that means here 2 wattmeters changing its values based on that, based on what the, based on this load. Dear students, just you remember that here this is our motor. Okay. So this is a terminal box, R phase, Y phase and B phase. While it running from starting, and the current drawn from this line may be changes from starting to running condition. It will take some time. For example, this is an induction motor. Okay. Induction motor. At initially it will draw the current, this current, load current is a very high current. At that condition, the speed of the rotor is equal to 0. No back EMF in the rotor conductor, similar to the DC motors. It will draw some more current, nearly 5 to 7 times of full load current, okay, as a starting current, high starting current. That's why I am going to use one starter compulsory to start the induction motors. At the same time, the range of the current also changes based on the speed. If speed increases, then it will becomes the back EMF. At the same time, it changes its current also. Not only magnitude of the current as well as its power factor also changes. Once the load added on the motor, this power factor also changes. At no load, power factor is value changed. If the load is added, mechanical load is added in the motor, the power factor also changes its value. Okay. So if power factor changes means the voltage and current phase angle changed corresponding to this one, to produce the corresponding torque to meet the increased load on the motor. Okay. You will see this in final year level, how the induction motor works and how the torque is developed, what is the maximum condition of the torque, we will see in next semester. Okay. Now, as a second year students, you should remember that the current drawn from the supply is changed from no load to full load. At the same time, if load changes on the mechanical load changes on the motor, the power factor also changed this one. That's why the wattmeter is connected in two phases, changed its reading values. Just now we all elaborated them. Okay, so once again I am going to simplify, so summarize these values. This is very important. Okay, so let us see now. So what is the condition here? Let us assume first case and second case and third case or fourth case. Okay, now the current is taken this one. At that condition, what is the rama W1? What is the Lakshmana value? Okay, so now we are going to see it. And what is the condition also? The PF, power factor, okay, at the power factor, and at the same time angle, power factor angle. Okay, this value changes. How these values are changing in W1 and W2? This one, what is the value changes? Now first case, you take the first case one. First case, at power factor is equal to unity power factor 1. Power factor is equal 1 condition. Power factor is a UPF. And the UPF means the voltage and current are both direction. The phase angle is the 0. Okay, phase angle is the 0. Then W1 indicates positive value in clockwise direction, and W2 also in positive value. At this condition relation, so here W1 is equal to W2. So both brothers are equal strength, both are positive direction. Okay, the second case, what has happened? When the motor takes at unity power factor, the W1 indicates a positive value, W2 indicates the positive value, and this indicates the equal values. For example, the 60 watts, W2 also 60 watts. Suppose W1 is 100 watts, W2 also 100 watts. Total power is equal W1 plus W2. Okay, so that is a total power. You can take that is also total power. Total power is equal to W1 plus W2. Okay, so that is the ring. So what is the nature? Both nature. Now second case. In second case, the power factor. So that is called, what is the power factor? In this case, we can take that power factor in between 0.5 to this one. So this is that means the power factor, this is called voltage, this is equal to 60 degrees, current, angle is equal 60 degrees. If in between, that is equal power factor 0.5 less than 1, in between less than PF less than 1, in between here in this case, okay, 1 and this 0.5 in between, what will happen? That means here angle is equal to 0 to 60. Okay, so from 0 to 60 angle. Okay, so you can see this one. Okay, you can write it. So what is this one? PF 1. Angle is equal to, so 0 to 60 degrees in between. Then what is the rama? Rama always positive. So moving in clockwise direction. Here also moving in the clockwise direction. Now in this case, Lakshmana also positive direction, moving clockwise direction. But in this case, Rama will show some more reading than Lakshmana. Okay, so here W1 is reading will be always more than the W2. Please remember it. Then what is the power? Same, W1 plus W2. This is the second case. Okay, now third case. What is the third case? Now in this case, the power factor exactly 60 degrees in this case. Now first case, in between a third case. Okay, so that is equal to power factor PF is equal to 0.5 and angle is equal to 60 degrees. We derived this also. Okay, then what is happened? Rama always positive in clockwise direction. Now our Lakshmana under comma, that is equal, W2 indicates 0 readings. Okay, Lakshmana will indicates no readings. So at that condition, so what is the total power? So here 0, the total only Rama will lead the war. Now what is the total power? Total power is equal to W1 only. Okay, this is exactly at 0.5. And fourth case. Dear students, please, this is very important in competitive exams, and at the same time you can enjoy this, how this value after machine changes is a load. Okay, then fourth case, you can see if the load, now this is what is happened here. Okay, now this is a voltage, sorry, this is a voltage, this is a V, and correspondingly the current is, now in this case, fourth case, I am going to write it more than the 60 degrees. Now previously we taken as a reference this one. Okay, now here the in between, this is a 0.5, this is equal 0, this is equal 1 power factor. Okay, this angle is equal to, is changing, this is the angle. Okay, now this angle between power factor is equal in between. What is the power factor now? The power factor is equal to, so 0 less than PF less than 0.5. The power factor between the this value. Okay, so 0 to 0.5 value. What is the phase angle? That may be greater than 90 degrees. Okay, 5 and less than 60 degrees. In between. Okay, above this, in between. Okay, not less than. So in between. Okay, this value. What is happened? So what is the Rama value? Rama W1 always the positive in clockwise direction. Now Lakshmana in this case, he is going to the, under treatment, is going to the negative value. So moving anti-clockwise direction. Okay, now what is happened? In this case, W1 magnitude is greater than W2. Okay, so total power is equal to, we are going to get the positive. So that is called W1 plus W2. So it is equal, total power is called W1 plus W2. So always we are going to the positive value only. This is another case. Now, and fifth case. In fifth case, exactly this one, at phi is equal to 90 degrees and power factor is equal to 0. Okay, the PF is equal to 0, phase angle is equal to 90 degrees. Then what is the Rama? Rama is always Rama, so positive value and clockwise direction. Our Lakshmana, then is also negative value, still is a negative. Then here what will happen? So here what will happen? So magnet, the negative value is more of Lakshmana, then what will happen? W1 magnitude, whatever the W1 equal to the W2 magnitude, but in the opposite direction. Okay, the total power indicates what is the, so for example 80 plus 80 minus, total power is equal 0. So here total power is equal to W1 plus W2, same. So plus 40 minus 40, that becomes a 0. These are the conditions of load. Okay, dear students, so you can see here, so this is a diagram. Okay, how the motor current, power factor changes, how the motor behavior, at the same time how the wattmeter's behavior changes, you can see at a glance. Okay, so when what is happen? So here 1 wattmeter W1, another wattmeter W2, and sorry, this one connected here, and this is a current taken by this one or motor, and if the mechanical load changes, this current IR, IY and IB changes. How it is changes we have seen now. Okay, so that means we know that this voltage VL, that means here simply we changing. So here that the relation between the V is the husband, you can take the husband, current is the wife, just you take it. What is the relation between this? Both are relations are based on the relation their family situations, improvement depends. Now what is happen? So W1 and W2, for example children's value, Rama and Lakshmana value. So based on this father and mother behavior. Okay, so this behavior depends upon the load on the mechanical load. How the load on the motor, this values changes, correspondingly this values changes. Two children, Rama and Lakshmana, that is depend upon the and father and mother behavior. Okay, now what is first case? What we have seen? First case, this husband and his wife both are quarrel each other, that's a mutual each other, is understanding, very good understanding. That means power factor cos phi is equal 0. There is no difference between the any difference between their behavior as well as the decisions or support, always they are the support each other. V and I both are in same direction. I am going to this direction, I will follow you. I will go, I will eat this one, I will also eat it. Similarly, they are cooperate each other. Then children's W1 and W2. So what is happened? W1 and W2, that both W1 and W2 are equal, happy and equal, both are equal. The children are happy, both are, they are also happy. And second case, what will happen? If the phase angle changes, the voltage that is equal to husband and this is a wife, there is a disputes between the husband and wife, that is maybe for example phi angle. Then what is happened? Then at this condition, one W1, one son is a positive value, another son behave is a lazy fellow, is a 0 values. Next, Further, third case, further husband, wife increased to the 90 degrees, disputes increased, there is a divorce between the a stage of divorce, the quarrel very much. At that condition, the effect on children's W1 is positive, but W2 is negative, but entirely opposite to his brother, similar to the this I and voltage. Then total power becomes to the here, the development of this family become to the 0. Here the family development is equal to burden on the this one, only it becomes the half of its development. Where both are equal, the development is perfect, the full, both are sons are equal. So dear students, you also in the society cooperate, help each other, then you may become better than other peoples. Okay, so after all, these meters also behave in such a way. Why can't we? Please read it, you can enjoy it. Okay, so let us summarize this topic. Okay, same this one, we have drawn these figures. Once what has happened, the power factor, first case serial number, the power factor, the wattmeters W1 and W2 are remarks, and in the power factor is a unity, then W1 positive and W2 positive and W1 is equal to W2. In second case, the power factor in between the 1 and 0.5 lag, then both wattmeters are positive, but in this case W1 indicates a more value than the W2 value. A third case, when exactly the power factor is equal to 0.5, at that condition the W1 indicates a positive and W2 becomes shows the 0 value. So the total power is equal indicated only in W1. And fourth case, if the power factor below 0.5, then W1 indicates a positive and W2 becomes the negative values. The difference of that value will give us the total value. And last case, when power factor is called 0, that's disputes between the V and I is a more and more extreme 90 degrees. Then, so in children's W1 becomes the positive and W2 becomes the equal to the W1 but is a negative direction. Then total power is equal W1 plus W2 becomes the 0. Okay, so please remember this W1 and W2 readings at different power factors. Okay, so I think you are enjoyed this thing. So these are the 3-phase power measurement with help of single wattmeter in a balanced load in 3-phase circuits, 3 wattmeters used to measure the unbalanced in 3-phase circuits, and 2 wattmeters used in balanced and unbalanced loads, and we analyze the behavior of wattmeters based on power factor. Okay, dear students, still you have any doubts, please ask in next class. Thank you for listening my class.